But from the base word calculus comes from the Greek words calculus. Even your calculator also comes from these words, calculus. So what is basically calculus? Why does it have something to do with mathematics? So calculus, by the original name of calculus, infinitesimal calculus. Infinitesimal calculus. This is the real name. The original name is 1600 BC. Alright? The one that is introduced in infinitesimal calculus is by two pioneers. We call, I think most of you remember one of it, or maybe you might know that one person, Newton Isaac. Have you heard about Newton Isaac? Come on, just. And the second person that is actually introduced calculus is what we call as Gottfried Leibniz. So Newton Isaac born in England. Gottfried Leibniz born in Germany. Okay? So these two persons or scientists that actually discovered about calculus. So what is basically calculus? When we say calculus, it's all about calculate. Alright? The base word calculate. So calculate is what? To measure stuff. Alright? So that is basically the ideas of calculus. So now, why we have to learn differentiation and integration? So, to get a clear ideas on why we have to learn these two topics, I got a video for you to see. And I need you guys later in a group discuss. I will give you a time to discuss what does the videos actually try to tell us about calculus. Is it okay? Then only I will explain again what is that video tells you all about. Okay? Alright. Are you guys ready?
Yes.
Math is not just meaningless formulas that, despite what you might have thought, math is not just meaningless formulas that pop out of nowhere. Even though you might not be able to see it, it's everywhere in our universe. Among the realm of mathematics, there's one particular field described by the Nobel-winning physicist Richard Feynman as the language of calculus. Scary, huh? Well, it's basically just a description of changes in our ever-changing universe. Normally, when we talk about changes in stuff, we talk about the difference in the amount of stuff after the change. Well, we can also talk about how fast something changes, the rate of change, how much something changes in a period of time. To find the rate of change of the height of the speed graph, we found out how much it has grown within a period of time. Dividing the height by the time gives you the rate of change, 1250 meters per second. Easy, right? But if you're a good observer, you'll probably notice that most things don't change at a constant rate. So the method I just mentioned doesn't really indicate variations in the rate of change throughout the entire motion. Perhaps we can chop the motion up according to its speed, like fast period and slow period. Yeah, but it's perhaps still not precise enough. How about dividing it into smaller chunks, like tracking a change in the distance every second, millisecond, nanosecond, or even 0 seconds? Wait, what? Nothing can change with 0 seconds when time doesn't even count. Well, even a powerful subject like that can't change something absurd into something sensible. What we can do is to record the change within an infinitely small period of time. Almost 0 seconds, but not exactly 0. Call this small period of time delta x. As delta x decreases, you see the rate of change approaching a certain value. And from there, we can approximate the rate of change at a specific moment. This process is called differentiation. What's so amazing about calculus is that not only will you use it to find an instantaneous rate of change, but also to do the reverse. Given how quickly something changes, we can know how much something has changed. To find out the distance traveled in the speed, we can multiply the speed at a change in time. But what if the speed is not constant? Well, we can chop its motion into very small periods delta x, and then add all the distances traveled with each small period up to get the total change in the distance throughout the entire motion. As delta x decreases, approaching 0, you can see the total change in distance approaching a certain value. This process is called integration. You might ask, Why do you care about calculus, possibly like exams? Well, many people do care. Scientists discover the changes in our natural world, engineers use it to optimize the design, and economists use it to optimize problems. Even if there isn't any point in your life you have to apply calculus to real-life problems, well, isn't the ability to see the world in another language pretty amazing?
Alright guys, so do you need to watch again or how's it? Do you understand what this the video tells you? I can see all the alright. You need to watch again? I want to start discuss now. Once again, because there's late couples here, especially you. You're late. I'm fall asleep. Only mistake. It's considered late. Alright, so I will give you one more time to watch it. So the clear ideas, I give you the ideas. So why is it they call it differentiation? So what is the studies of differentiation? What is basically differentiation? We had learned differentiation previously, right? And we notified that differentiation is all about dy dx. Why is not something else like velocity over time? Why there must be d in front of it? So what is that d stand for? Have you taught yourself? Curiosity comes in. Why is it we have to use dy? Just use it, right? Because that is what the teacher told you to do. Alright? But what is the reason behind it? Why this thing become d instead of other alphabet? Why is it delta? You might ask yourself, right? So we are speaking about the infinite number system. What happened if the time gets so small, approaching zero? Not zero, because math also cannot explain. Everything that divided by zero is a undefined values, right? Infinity. But approaching zero means 0.00001. What happened to the values by the time approaching zero? So what happened to the velocity of the birds? Right? So in the long range of time, you can see, oh, the bird is actually flying at 60 meters per second. But what happened if the time gets smaller? So that is what the video is trying to tell you. And when it talks about integration, why is it integration? Is the reverse process of differentiation. And the time gets smaller, you can have a significant distance traveled by the birds. Am I right? So I will replay the videos. You check the word, every word, understand the word. Infinite numbers, the distance, the velocity over time, the growth of the plant, remember the sprouting over the time. So all these you have to get into your mind because that is the basic we call pre-calculus studies. Alright? Before you go for further studies, we call infinitesimal calculus. Calculus itself has three types of calculus. Calculus 1, 2, and 3. What we learn now is pre-calculus, not yet calculus, just the intro of calculus. Okay? So, once again, last video.
Despite what you might have thought, math is not just meaningless formulas that pop out of nowhere. Even though you might not be able to see it, it's everywhere in our universe. Among the realm of mathematics, there's one particular field described by the Nobel-winning physicist Richard Feynman as the language of thought, calculus. Scary, huh? Well, it's basically just a description of changes in our ever-changing universe. Normally, when we talk about changes and stuff, we talk about the difference in the amount of stuff after the change. Well, we can also talk about how fast something changes, the rate of change, how much something changes in a period of time. To find the rate of change of the height of the speed graph, we found out how much it has grown within a period of time. Dividing the height by the time gives you the rate of change, 1,250 meters per second. Easy, right? But if you're a good observer, you'll probably notice that most things don't change at a constant rate. So the method I just mentioned doesn't really indicate variations in the rate of change throughout the entire motion. Perhaps we can chop the motion up according to its speed, like fast period and slow period. Yeah, but it's perhaps still not precise enough. How about dividing it into smaller chunks, like tracking a change in the distance every second, millisecond, nanosecond, or even 0 seconds? Wait, what? Nothing can change within 0 seconds when time doesn't even pass. Well, even a powerful subject like math can't change something absurd into something sensible. What we can do is to record a change within an infinitely small period of time, almost 0 seconds, but not exactly 0. We call this small period of time delta x. As delta x decreases, you see the rate of change approaching a certain value. And from there, you can approximate the rate of change at a specific moment. This process is called differentiation. What's so amazing about calculus is that not only will you use it to find out the instantaneous rate of change, but also to do the reverse. Given how quickly something changes, we can know how much something has changed. To find out the distance traveled with the speed, we can multiply the speed and change in time. But what if the speed is not constant? Well, we can chop its motion into very small periods delta x, and then add all the distances traveled with each small period up to get the total change in the distance throughout the entire motion. As delta x decreases, approaching zero, you can see the total change in distance approaching a certain value. This process is called integration. You might ask, why do we care about calculus apart from failing exams? Well, many people do care. Scientists use this to discover the changes in our natural world, engineers use it to optimize their design, and economists use it to optimize problems. Even if there isn't any point in your life that you have to apply calculus to real-life problems, well, isn't the ability to see the world in another language pretty amazing?
So, what do you think about the video? Are you able to get it now? Stupid. Alright, so I will give you 3 minutes, okay? Try to discuss with your friends inside the group, alright, the given group now. Try to get something, at least something that you understand from the video. Because later, if you want to learn calculus, you need to learn all these ideas first. Then only you realize what is the function of us to learn calculus. Okay? Just 3 minutes. Can you do now? Alright. Come. Time set now.
differentiation and integration. So differentiation is used to calculate the rate of change. So to simplify rate of change just means that how much change happens in either 1 second, 0.1 second. However, integration is the reverse of it. So integration is just how much change happens. So as Anis example before, just about how much distance travel. So let's say if we have the equation of the velocity of the, let's say if we throw a stone up in the air. So if we integrate the equation of velocity, we get the distance.
Okay, thank you. Same ideas. So let me explain to you. Thank you so much for those group. I'll actually give you another 10 marks. So which group are you? Group? 4. 3. 10 marks for you. Okay, good. So now let me explain what this video tells you. So music and before we introduce what we call infinitesimal numbers, during that time I think you remember the histories of Isaac Newton, where they can see the fallings of the apples, right? So music I think thinks about that. Why is it the apple is falling to the ground, but the moon, as you see, is not falling to the ground, hitting the earth itself, am I right? So you might ask yourself, what is it? So Newton Isaac talked about, oh, there must be something that make it to drop to the ground, which is gravity. We all know that, right? So what makes the moon is actually hanging, alright? Not crashing to the earth. But why is it the apple falling to the ground? So when we talk about the gravity, Einstein always draw this. This is a common idea in physics. For those who are learning physics, they know what this. So over the change, Einstein see that over the distance, okay, as the distance that increases, the gravity, right, the gravities of the falling drop down. So that's why the apples is close enough to the earth, am I right? So that's why the gravity pulled by the apples, means the gravity pull on the apples is higher compared to those who are actually further away, which is the moon, am I right? So when Newton Isaac says about these ideas, they talk about if that one is so different, the gravity pull is different, but what happens if the object is really on the gravity itself? So there is a lot of history behind this. I don't want to talk about this more, but what we know from the videos that we are supposed to learn is Isaac Newton tried to explain that. Let's say if you see a bird flying just now, right? We had 60 meters per second and 5 meters per second, right? So over the bigger period of time, you can see the bird is actually changing in velocity. But for small changes of the velocity, how much is it? So that's why we learn differentiation. What differentiation? Let's say this is the motion of the bird. Velocity, displacement over the time. Now, velocity, because displacement over time is velocity. Speak about velocity. I'm talking about the physics a bit, but it's okay. The motion of the bird, S versus T, showing you all the velocities of the bird. Am I right? But common sense, if the bird move in a straight line, so straight line, we studied about straight line, right? So the gradient of a straight line is basically constant, am I right? So this one we can know that every increment of the velocity is constant, like 2, 4, 6. This is easy, am I right? But what happened over the same period of time, the velocity is not the same. Understand that? Because you are changing in velocity. Sometimes the bird is actually speeding up, then suddenly going down, slowing down. Am I right? So how do we investigate the motion of the bird? So that's why Isaac Newton tried in the graph itself, because we studied about the curve, right? Over the bigger period of time, let's say you take T1 and T2. Over the bigger period of time, you can say that these two lines is a straight line, am I right? So this one over the bigger period of time, you can see the velocity here is constant, am I right? But what happened throughout the curve? So that's why in the video, Newton Isaac tried to explain here, what happened if I wanted to know the small portion of the interior's rate of the time? So that's why Isaac Newton in infinitesimal says that what happened if we try to squeeze the time to a smaller number? Understand that? So when the time gets to approaching 0.0001, you were able to find how much is the rate of the displacement over time, which is the velocity of the bird for a small portion of time. That's why in differentiation, we studied about the small changes of the time respecting the small changes of displacement. So this is what we call the tangent line. Am I right? Remember when we learned differentiation, we talked about dy dx. So what does the delta here stand for? The delta here stand for small changes in x give you small changes in y. So dy over dx is basically the gradient of who? Gradient of tangent. Am I right? So for a velocity that is changing throughout the motion over the medium period of time, we can study about the small changes of velocity when the time is smaller. Understand that? So that's why, how to explain if things are bigger like this one? So if the velocity of the bird is flying over the period of time, it's different. So if you take the whole curve, you will find what we call as the mean velocity. Am I right? But what happens if I need only for small changes of time, like 0.1 second? How much is the velocity? That's why we have to learn differentiation. For small changes of time, we differentiate across the tangent line. Understand? Are you guys understand this? Whereas, how about integration? Integration speak about for these small changes of time. Every time when the bird flies over a small period of time, you can find how much the distance traveled by the bird. Am I right? By integrate the function. Am I right? When you integrate the function, you will be able to find how much is the distance traveled by the bird over the small period of. Okay? So if you have more smaller interval, means more exact distance traveled. Understand that? The smaller the time, the exact values of the areas. You understand what I mean? You get what I mean? So that is integration, finding how much the distance traveled by the by the bird. Whereas differentiation speak about how much is the change of velocity over a small period of time. Next time we have dy dx. Okay? Okay? Are you guys okay? So this is only small portion of calculus. To explain it more, we have to go for secant, all this thing. But we are not going to that because that is not your job. Okay, guys. So come back to what we are supposed to learn. So if you see this, I got a calculus graph here. We studied about, so basically calculus also studied about the graph, the curve. Alright? How to measure the curve. What does the curve tell us? So what we can say here in differentiation, if let's say I got a tangent, so you see the tangent to the curve here? So it's moving around, right? So if I studied about the tangent, studied about the differentiation, we studied about the changes of the velocity over a small period of time. Am I right? So the tangent is always tangent to the curve, right? Tangent to the curve. Until when we reach, when there is no tangent parallel to the x-axis. So dy dx is 0. Am I right? So all these can be shown here. So that is what we studied. So whereas for integral, when we studied about integral, we studied about how much is the area covering up under the curve. And how much the area covered in. Okay, so the areas covered in integration are known to be the distance traveled by the bird just now. Am I right? So that's why we have to learn differentiation and integration. When time gets so smaller, so how is it we can actually find the exact values of the velocity instead of finding the mean velocity? So all the birds flying, velocity is so many. If you find the whole thing, you find the mean, right? You don't even know what is the exact values of the small changes of time. But if you learn differentiation, dy dx states that I can able to find the small changes of the time by using the tangent. So the tangent would come from the tangible, means touching one point. So this point we call instantaneous change rate, change of velocity. Understand? Or displacement. It's up to you what you're investigating. Okay? Can I? Alright. So come back to what we are supposed to learn today. Integration. So before we learn integration, before we studied about how to find the areas under the curve, how much the distance covered by the bird flowing, right? We also need to study about how to actually integrate. That is common characteristic of integration. Okay? There is the first topic, the first subtopic in integration. So how to differentiate integration? How to differentiate function? Alright, now. First thing, previously in differentiation, let's say if I got dy dx equals to 2x. That is differential equation, alright? Differential equation. The first derivative we call it dy dx or f prime x. So how to integrate this? So to integrate this, because we are looking for the areas here, you need to look for the curve, am I right? So in order to look for the curve, what you need to do is, do you see the dx here? You bring to the other side, am I right? 2x dx. And only you start integrate, am I right? So this is the step you have to follow. Dy dx, the differential equation from the first derivative changes to equation of the curve. So the job of this to look for the equation of the curve. So how we do that? Take the dy dx, bring it to the other side. Right? Dy leave it here, 2x dx. Why we leave 2x with dx? Because 2x respect to the same x. Understand? So how do we integrate it? Integrate the first thing. Integrate, this is basically integrate 1 dy. So in integration, the rules is simple. When we had 1, so 1 is a constant function, am I right? 1. So 1 also known to be x power of 0, am I right? Integrate x power 0 because x power 0 is always 1. Everything at power 0 is 1, am I right? Respecting to dy. Same thing here. This one, 2x power of 1. Respect to dx. So in integration, how are we going to integrate? The power, the first step, power, once you integrate the sign loss or loses, okay? You lose the sign once you integrate. So power plus 1, and first step, divided by the same mu power, and so dy, what happened to dy? Loss. Okay? Sorry, this is y. Sorry. Respecting to y. Sorry, because y with y, x with x, sorry, So again, I repeat, when you integrate y, the power plus 1 divided by the new power, am I right? So the dy loses the integration sign loss. Okay? So what happened the next thing? Here, 2, the power of the x, same thing, plus 1 divided by the new power. Okay? The dx lost by in dx, because y respecting, because you are looking for the equation of the curve, right? When you look for the equation of the curve, the dx tends to be constant integration. Okay? Are you guys okay? Okay, now. So y, power of 1 is always y, right? Divided by 0 plus 1 is 1. So still maintain y. Am I right? Then equals to 2x. 1 plus 1. 2. Am I right? Divided by 1 plus 1 again. 2. So 2 and 2 can cancel or not? Okay, cancel. Plus c. So this is your curve equation. Am I right? That is your curve equation. So from differential equation of first derivative to look back the equation of the curve, we need to go integration. That's why integration known to be a reverse process of derivative. Okay? Right now, let's say, I give you another example. Let's say if I got the differential equation of dy over dx, 2x x squared. Let's say if I got x squared plus 2, for example. Okay? So how are we going to integrate here? Okay, now. First thing, dy, put it that way. Integrate x squared plus 2 respecting to dx. Okay? Next step. Remember this is always 1, right? So y power of 0 dy integrate x squared plus 2 respecting to dx. Okay? Next, y power 0 power plus 1 divided by the new power. Alright? Equals, remember all these laws, lose all the integration sign and dy. This one, power plus 1 divided by the new power. Alright? Easy, This is quite easy. How about 2? Same thing, x power of 0. Am I right? Because 2, x power 0 is always 1. Beside the 2, they always have x power of 0. So same thing, follow. The power of the x were plus 1 divided by the new power. Then plus c. So I will explain to you what is this c. C is basically constant of integration. But why is it we have to put c? Okay? Now settle down. Y equals to x power of 3 divided by 3 plus 2x divided by 1. So same thing, 2x. Plus, so this is what we call equation of the curve without the constant of integration. So now, why we need to have constant integration? First thing. Okay. Yeah. Why we need to know the integration? Okay, now. Example. We had what we call as when x squared. X squared is what kind of function? Quadratic, right? So when you differentiate quadratic x squared, what will you get? When you differentiate equation y equals to x squared, what do you get? Linear, right? 2, which is 2x. Fine. So if the derivative of unknown function 2x, then the unknown function, so why is it we introduce constant integration? Well, let me explain. When we had x squared, when we differentiate x squared, y equals to x squared. Differentiate dy, dx, we got 2x. Am I right? So what happened if I got y this time around? Same function, just that this one has y in the center. You differentiate, how much you get? 2? But you say, teacher, integration is about reversing process. But if I reverse process, both of these will get the same thing, right? Integrate this, you said the same thing. X squared plus c, am I right? This one also the same thing. X squared plus c. But which one is the right equation? How am I going to know that this is actually x squared plus 3 and this is only x squared? So who's going to tell that? The constant integration. Understand? By only this c. The c itself will tell you which one is the right equation of the curve. Understand? Are you guys okay? So if you're not looking for c, if you forgot about the c, you might have a wrong equation of curve. Understand me? Okay? Clear? So how to find c basically? So c is basically a point, the x, any point, right? Around it. So you treat it like a normal equation, What you need to find c is the the coordinate. Am I right? The x, y. When you put in the y and the x, then only you can look for the c. Am I right? So what point is this? Anyone? Where should I get the point? Huh? Stationary as long the point is on the, understand that? It cannot be any point that you want. That teacher, I want this point. No. The only point will be accepted is the point that is actually existed on the curve. So usually, if you start integration, we always start from the differentiation, right? First derivative, right? So always look for the stationary. Am I right? Okay? Clear? Right? Okay, now, let's say, so I don't have to speak all this because this one is just to return back how to differentiate, how to integrate and all that. Right? So in summary, to integrate a power of x, what happened? The first step, if you want to integrate, the first step is what? Increase the power by 1. Then, the next step, what you should do? Divide by the new power. Okay? Alright. So next, how to integrate sum and differences. So how to integrate sum and differences? The first thing, anyone wants to try? Integrate sum and differences. So again, same thing in differentiation. We also differentiate sum and differences in differentiation, right? But this time around, we need to integrate sum and differences. So let's say, if the question gives you, find the integral of means that the differential equation is dx, dy, dx equals to 1 plus x power of 7 plus 1 over x squared minus z. Am I right? Okay? So how to find the integration of this? dy respecting to dx. Am I right? dy limit here. Remember y power of 0. So the whole thing here integrate 1 plus x power 7 plus 1 over x squared minus z x. So the first thing you need to do is everything that you see reciprocal, what I need to do. Those who see reciprocal, what you need to do? In differentiation, if you see reciprocal 1 per 1 per, what you should do with the per? Bring it. Okay? So that is the step. Y 0 dy. Bring it first. 1 plus x 7 plus x power of negative 2 minus x z power half. Remember? So now you start integrate. So integrate y power of 0 y. So then dy. So dy lose, integration lose. And this one 1. How much you get? Okay. X, because 1 is also known to be x power of 0. Alright? So the power plus 1 divided by the new power. Am I right? Plus x7 power plus 1 divided by the new power. Am I right? Okay? Follow the same thing. Power plus 1, careful. Plus 1, negative 2 plus 1 divided. The same thing, negative 2 plus 1 by the new power. Take the whole thing. Minus power plus 1 divided by power, new power. Then plus cx here. Okay? Then, so how much is it? Y x plus x8 divided by 8 plus x power of negative 1 divided by negative 1 minus x 3 over 2 divided by 3 over 2. Do not leave it this way. Max, you don't like it. Simplify it. Make it nicer. So how to make it nicer? X plus x power of 8 divided by 8 plus minus. You got? Minus. X power of negative 1. Bring it down, become 1 over x. Good. Then minus x 3 over 2 divided by 3 over 2, it became 2 over 3. 2 on top, 3 down. Plus, okay? Okay? Is it clear? Okay, now, should we select who's going to answer for example 2. The group, which group? Prepare. Oh my God, like this. Group 3. Any volunteers? Group 3, come. Faster. Example 2. Oh, this is group 3. Now, don't worry, just try. Wrong is okay. No one will scold you. Oh, scold you, don't worry. Group 3, come. Take your time. Wait. It's okay. Your time. Example 2. I need 5 minutes for you to try the couple of things. x squared minus x divided by x half. Am I right? So if you see a reciprocal, what do you need to do? What do you need to do, guys? Bring it up. Bring it up. Follow the process. Bring it up. So that is what happens. The power becomes negative. Am I right? Bring it up. Then only what you need to do? You times this into each of the factor. Because we cannot integrate with so many x here. Am I right? You can only start to integrate when there is operation in between of the term. Am I right? But now, this one got term. Operation, am I right? 1, 2. But this one, times the whole term. So open up the term. Understand that? Open, times it. Open the bracket, times it. Open up the term. X negative half, times it. So x squared minus x. This is the answer just now. Because we cannot clearly see here. Negative half. Am I right? You times it. When you times it, x squared times with x negative half. Am I right? Then how about this one? Minus x power of 1, x negative half. Am I right? Is it okay? Okay, now, if base are the same, power were plus together. Am I right? Base of the x the same, power were plus negative half. And same thing here. Base x is the same, power were plus. Okay? Indices, index numbers. When base is the same, power were plus. So they will become 2 plus minus. 2 minus half. How much you get? 2 minus half. How much you get? Common max. How much? 3 over 2. Then 1 plus minus. 1 minus half. How much you get? Half. Then only you start to integrate. Integrate this. Respecting to dx. Understand that? Then you start integrate. The power will plus 1 divided by the new power. Alright? Minus power plus 1 divided by the new power. Am I right? And plus C. So that's what happened. Power plus 1 divided by the new power. Power plus 1 divided by the new power. Careful, group 3, already mentioned. Once you start to integrate, what is losses? Lose this. Lose this. This one, integrate become 1. Am I right? Once you start to integrate all the dx, lose. Okay? You cannot have that. Then you need plus c. So 5 over 2, bring it up to 2 over 5. Invert. Invert because divided by 5 over 2. Invert, change place. 2 over 5. 2 over and English. Is it okay? Okay. So now, I had some count here for you to play. I'm hoping that we have time, but it's okay. We try to do that. Just take a few minutes. It's just 10 minutes. Can we start now? Are you guys ready? It's a simple question. Okay? But one of the question or two of the question might ask you about the differentiation as well. Okay? Just to recap what you understand about that differentiation as well. Okay? Are you guys ready? So Kahoot, I need you to open your Kahoot online. So this is the ID. Kahoot ID. It takes too long. Get ready? So get a pin. Alright, these are the pin. Come. Stand now. Each and every one of you has to try. So we will see who is the highest will be the winner of interval binding equation occur, right? You will see a different differential equation later. Done? Anyone else not in? Just go to Google, type Kahoot online. Then you will automatically top out. They will ask you for again. Yeah. This one, Kahoot, Kahoot. Go internet. Your internet is so slow. Alright. Done? 27. How many of you know? 27. Ayah. 27. Ready? Can we start now? Be careful, read the question carefully. You need a paper and pen as well. So start now. Very simple question. There's only two challenging questions. Don't bring me through the 3x squared plus 4x plus 3. Faster. 29 seconds. 3x squared plus 4x plus 3. Question number 2, come closer, you cannot see. Take the question first. Alright, next. This is a winner. Wow. The right answer is yellow, right? Oh my god, this is so bad. Who is the winner this time? Hafiza. Good. Hafiza also on top now. Sophia, the second, Iman the third one. Midnight Walkman. Number 3. Come. This is easy. Don't ask me why. 0 lah, that is a key. You ask for section anyway. All that is differentiation integration only the last one. Anyone else still Come on, one more minute. Differentiation and integration is two different processes, but integration is the biggest process of differentiation. So the clear idea of differentiation is to find any change with time, any change with any variables that you want. That's why when we studied about couplers, we are studying about variables of x and y. So x can be anything, y can be anything. Understand? If you talk about the bird just now, the speed, alright, we are talking about the displacement over the time variables. Understand? So as the space goes beyond that, bigger time, you can see the average speed of the bird flying. But over the small period of time, you will see a small portion of the velocity of the bird. Understand? Whereas integration, simple idea to find how much distance covered by the bird. Right? There's a reason why you have to learn couplers. This is just three couplers. You will learn much more deeper later. Talks about circle, secant values, anything. Couplers is so big. We have three types of couplers. This is just one of them. Okay? Thank you so much. See you again.